Good evening. Today we are continuing with the risk management, that is project risk management. We have yesterday talked a bit about what project risk management is, what are the various processes of project risk management. Also, we did talk about some of the introductory concepts about the project risk. Today we are moving on with with the second process, which is identify risk. We started it yesterday, and today we are talking about its tools and techniques. So we did talk about the types and categories of risks. Now, when we are trying to identify risks in our project, what are the various information gathering techniques we can use? These are normal techniques which are otherwise also used for many purposes, like when you are collecting the information, collecting the requirements from the stakeholders, you apply some of these techniques. You use the brainstorming there, you use interviewing there, and several other techniques there. But these certain techniques will also be used here for gathering information about the risk. Brainstorming, as you understand, that this is thinking out of the box. The goal of brainstorming is to obtain a comprehensive list of project risks. Now, if you understand brainstorming is antithesis of logic. It is opposite of what do you call it, logical thinking. So logical thinking, although is very good, it links the things, and we establish our logic on the knowledge we have, on the established knowledge. But sometimes we have to break free from the bounds of logic and think of things which we otherwise cannot logically reach up to. So in brainstorming, we want to ensure that nothing leaves our sight. The risks which are logically visible, we can easily understand them and identify them. But those risks which we can't even think of uh, will remain unknown. So to make it possible that we can think of those things which cannot be otherwise thought, which cannot be otherwise reached through proper normal mental logic, so we use this brainstorming technique, which is a technique for the creativity. Creativity, you understand, is thinking out of the box. We are trying to conceive something which in itself may not exist. Thinking out of the box is giving the logic behind. So how can we think out of the box and try to identify such risks which are otherwise not visible to us? Uh, First, I must explain it to you how creativity works. Probably we discussed it yesterday or not, but normally we are basing our decisions, our thinking, our logical thought on the knowledge we have acquired in our lives. We base everything on our experience. And we understand that sometimes the experience of one person is different from the other person. But because I own my experience and I have more confidence in my experience, so that might become a point of conflict. And I am ready to fight over it because to defend my point of view. That is what my knowledge is. So that means everybody does not have the same conception of the knowledge. Everybody has viewed the same facts from maybe a little different angle, but generally there are certain universal truths which we generally agree. But the perception is different. Moreover, there is a lot of knowledge which is yet not explored, which seems and looks impossible to us. But if someone explores that knowledge, someone invents that, discovers that thing, and establishes a logic, then tomorrow we will be very confidently saying that yes, this can happen. It is just like that. uh, People many centuries ago could never have thought that man could go on moon. They could never have imagined that earth is round, because that day's logic did not support these dreams. They were just like dreams. So somebody dreamed about these things, or somebody thought about these things, and then it was proven. And now we all believe it. So there are many things which we don't know, but they actually exist in the universe. And when we certainly somebody finds them out and that knowledge is available, then we start believing it. But again, from our own perception. So we are trying to get you to think creatively and think out of the box and think of things which otherwise may be ridiculous. They may not have any logic. So in brainstorming, we prompt the people to think, which is like, a ridiculous thought. So I may ask you to give you a cue which is illogical in nature and ask you, okay, basing on something unrelated to the project, can you think of a risk to the project? Like, you see, you may say, yes, well, maybe third world war starts tomorrow. Whereas we know that such a happening has not a great chance of occurring. But once this point comes up, we will think over it and see, well, can something like that occur? We say, okay, world war probably cannot occur, but yes, there could be a big disaster. And what kind of disaster that can be, and then we can talk it out and establish a link, and maybe we can identify some kind of a risk applicable to the project. If we were thinking logically, we could not have found that. So the project team usually performs these brainstorming sessions, often with a multidisciplinary set of experts who are not part of the team. Ideas about project risk are generated under the leadership of a facilitator. Now, this is the disciplined way of doing it. Otherwise, you can go home and think on your own. That is the brainstorming or creative thinking you are doing yourself. But when it is done under a facilitator, then probably it is kind of a facilitated session in which your ideas can be brought to a ultimate conclusion. It could be in a traditional free-form brainstorm session or structured mass interviewing techniques. Categories of risks, such as in the risk breakdown structure, can be used as a framework. Maybe you can say, okay, let's take the technical risks only. What technical risk can be there? And then I give you a cue that a sparrow flies. So there is no concern of a sparrow flying in technical risk. But somebody will take a cue that sparrow is a bird, and um, technically it can go to up to this much height, or it can face this much of resistance, and he will come up with some idea about that height or flight. Another person may think that it is more about something tiny, so he may start thinking about very small risks. So it is the perception, whatever somebody can divert his mind onto, he can come up with those ideas, and any idea of those is welcome, because they may get us to some of the unknown risks, and we can identify them. When we are identifying the risk, we don't bother whether these risks are good enough or not. When we are identifying them, we are just listing anything and everything which comes to your mind, and there is a simple criteria that this risk should affect either or any one of the three project objectives: the scope, time or cost of the project might be affected by that. It must be uncertainty which could affect the scope, time or cost. If that affects scope, time or cost in any way, we will record it as a risk. Did you get any idea what I am trying to say? Yes, Mohsin?
Yes, sir. But one thing is a bit weird. Like once we are trying to gather like risk, I mean, think about risk. How can we leave the technical mentality or the logical mentality we think we use usually? I mean,
Okay.
it would seem as like illogical. I mean, if
It
we
is
start doing.
it is exactly illogical. This is it. This is the beauty of it. We want to think illogical and then try to establish a link with our existing knowledge and logic. We are playing a game. Like you see, okay, let's first talk about unfacilitated thinking, unfacilitated creativity. For example, I'm lecturing you here and you are mentally not present here because you are preoccupied by some other problems. So you are listening some part of my speech and you are thinking something else also. So that something else is completely irrelevant to the subject, but you are feeling, well, tomorrow morning I have to do this job, and once I go there, then I will also buy this thing, and then while I'm coming back, I'll be doing this thing. And in the meanwhile, I am talking about brainstorming and I am talking about risk identification, and suddenly you will try to relate whatever you are thinking to whatever I am speaking. Now this might look completely illogical, that when I will be going to grocery shopping, there might be some risks, right? So I must identify those risks. So you started using this knowledge in that thinking. Similarly, some of that thinking will come into this logic. What will happen is that the person who is fully attentive and following my stream of thought would would be restricted by the logic of talk, not to diversify. While you have already been diversified because you are thinking about, you are not even present here mentally. So wherever you are mentally, maybe you are shopping grocery and you have maybe a carrot in your hand which you are trying to buy. So you the idea of carrot will be sticking to your mind. So when suddenly I ask you, so what else, what other risk can there be? So your mind is stuck in the carrot. So maybe you try to make a story out of it and you say, okay, well, this project must be spotless, but because the carrot is red, so maybe the orange or red color comes to your mind, and you said, sir, there should be some uh, risk indication system by colors. Now this has nothing to do with the carrot, but the idea of color came from the carrot, and this you have brought in to this thinking. Although this might still look very ridiculous, but we might realize that yes, this is very important and we can consider some coloring scheme to different kinds of risks. So it is but natural that human mind tries to create the link from illogical to logical. And this very idea could not have come to anyone's mind until and unless he has gone through the thought process you have gone through. You got it?
Yes, sir. Like anything can invoke or provoke an idea which could
Exactly.
lead to something, you know.
Exactly. No matter how illogical and how ridiculous that idea is, still it may germinate something which otherwise we could not have thought. This is called brainstorming, and this is to explore the impossible, explore the unknown, And this way, we are sometimes able to identify many unknown unknowns and bring them into the list of known knowns. But still, I am not giving you a guarantee that you will always have all the unknown unknowns recognized, because this is not possible. There are certain things which are right now not visible and cannot be imagined even. So later on in the life of the project, when we progressively elaborate, certain ideas will then become clearer and then we'll be able to identify them. Then there is yet another technique which is called Delphi technique. Have you heard about a Delphi technique?
No, sir.
Delphi technique is a very interesting technique in which we achieve two purposes. Number one, completely uninfluenced and impartial view. And number two, a consensus of all parties without giving any importance to personalities. You see, when you are sitting in a meeting, um, you may have like-minded people sitting there, and you may have somebody with completely opposite views sitting there. And some people are so, enforcing that, and maybe that person is senior to you, and you are supposed to respect him. So whatever idea he gives, you do not want to contradict him. So you get influenced by the personality of the other person. Maybe your idea was much better which you wanted to give, but you have not, that idea could not be surfaced, and you started agreeing with that person no matter how bad his idea was. Just because he was more influential, that's why you could not bring good ideas on the table. So the first step is, somehow can we, if we can make the idea generation process anonymous. Can we do this? That all the ideas are entertained and nobody knows whose idea was it. All the ideas are anonymous. Maybe I asked you to please write down your ideas on a piece of paper and submit them to me. So everybody submits his ideas and nobody knows who gave what ideas. Then I take some time and I compile them into a list without mentioning the names of the people. And I show those points to everyone present and ask them to please comment and vote on which is the best idea, or top three ideas. So this way, there is no chance that anybody is going to be influenced by anyone else. And secondly, we are trying to gain a consensus in which maybe the maximum votes go to one point, and then second highest votes and third highest votes. So we understand that these three ideas are impartially agreed by all. So this is somehow we are achieving this, but practically this Delphi technique is not exactly like that. To keep it completely impartial, normally it is done offline, and we actually first identify all the knowledgeable people about the subject, and we send them the problem and ask them to send us the various solutions they have in their mind in just a sentence. So somebody will give 5 ideas, somebody will give 4 ideas. I will compile all the ideas and make a complete list of all the ideas without mentioning the names of the authors. I send this list back to everybody and ask them to look at this list, and you can vote for them, and you can say this is the most important idea, this is second best, this is third best, this is fourth best, and you can also mention that which are the three worst ideas. So that way you can sort all the ideas into a list. You can delete few ideas which are the worst ideas, and then prepare another list and then again send it back to all the people, and till the time they all reach a consensus on a set of ideas on, we will continue this process. This is a lengthy process, because if it is done offline, then it may take a lot of time because a lot of communication is going on. I gave you an example that even if you are 10 people sitting in a conference and you want to apply the Delphi technique, this is another flavor of Delphi technique, in which we rely only on the available people and still we try to keep their opinion anonymous and try to gain a consensus. This would originate some very good ideas, and good ideas have cannot be just simply thrown out. So this was a Delphi technique. Then we have interviewing. Interviewing is a qualitative method of collecting data. You talk to the people concerned, you talk to the stakeholders, participants, and subject matter experts, and you interview them, and qualitatively you list down what all are their opinion and what are the risks which they think are important. Interviewing is better than quantitative techniques because in qualitative techniques you can weigh and gauge which is the better idea than the other one. Then we have the root cause analysis. Root cause analysis is that you try to find the core reason of something. So this is also called, we already studied about Ishikawa, or what do you call it, the fishbone diagram. So this can help us find, as we studied in quality, we studied this thing in quality, and that was the root cause analysis. This is a fishbone diagram in which we have, like, in quality we said there is a defect and we are trying to find why, what is the cause of this defect. So we try to find that cause. Similarly, we try to find what could be the risk. If this thing happens, what could be the risk? So we try to hunt down the risk and therefore we identify the risk. So we have to put in all the effort to identify as many risks as possible. So this is one big technique, information gathering, and there are sub techniques within it, and there could be more. Okay. Then the next technique is the assumptions analysis. I explained yesterday that whatever assumptions we have been taking in the design of a project, where the data was not available, we assumed a value. And based on that value, we did all the subsequent calculations. But our assumption could be wrong. So this is a risk. So every assumption should be very thoroughly analyzed and monitored as if we know that this assumption still stands good or it has now been replaced by a fact. So assumptions are a very good candidate for the risk. So this is also another way of recognizing or identifying risks. Then we have got diagramming techniques in which we uh, try to analyze and see what else can happen to us. Like we mentioned earlier, the root cause or the cause effect diagrams. Process flow charts are very important because in process flow we have got the interaction between the processes, and we can see the linkages and we can find out which linkage might be at risk. So if we closely follow this, we will be able to at least find the sensitivity points where certain processes could be at risk. Then influence diagrams. This is a graphical representation of situations showing causal influences, like, if this happens, that it will affect that. So what are the major items which we want to see their effect on? So one thing will give birth to another thing, and that will affect yet another thing. So if we can follow this chain, we can also identify some of the sensitivity points and the risks. This is an example of your influence diagram. For example, you say that the risk condition might affect the project estimates and can also affect the deliverables. Project estimate will deliver the project activities and project activities will affect the deliverables. So what is the most sensitive point here, where there are more than one arrows coming onto? Deliverable is the thing which is sensitive. Risk condition is directly impacting it also, and project activity is also impacting it. So risk condition can directly as well as indirectly impact it. So we should identify such sensitive points as if we can find what can go wrong with it, what could be the risks. SWOT analysis, as I yesterday talked about, these are strengths, weaknesses, opportunities, and threats. Strengths and weaknesses are internal to your organization. If you understand the strengths your organization has, then you can build upon that strength. If you understand the weaknesses, you can try to curb those weaknesses. But this is something within your control. The risks are not actually under your control. Risks could be positive and they could be opportunities, and if they are negative they could be threats. So when we do the SWOT analysis, we do identify opportunities and threats, and those opportunities and threats can be included in the list of risks as positive and negative risks. In SWOT analysis, we usually divide our a paper into four parts. On top left corner, we write the heading strengths, and whatever are our strengths, we list those strengths down. Similarly, we write down all the weaknesses relevant to that situation, opportunity and threats. And after we have done that, then we think we take each one of our strengths and see how can we build upon it. We take each one of our weaknesses and see how can we eliminate or reduce our weaknesses. But again, I said strengths and weaknesses are in your control. But as far as opportunities and threats are concerned, they are not in your control. But how can you best utilize this situation? If there is a lot of the weather is very hot and sun is shining all the time, temperatures are going very high, maybe it is an opportunity that you can make solar energy out of it. And the same situation could also be a threat that you may die from dehydration. So you have to see which item is opportunity and which is threat, and such like opportunities and threats, you will then think about how to exploit them or to mitigate them. Risk register, when you identify the risks, you list all your identified risks into a register or a log, where you list down what the number of your risk is, name of your risk is, relevance, where does it relate to your risk breakdown structure, how much can it impact, what is the probability of it, what is the impact of this, and all similar uh, attributes of the risk are listed down in that register. So whatever data is known at this stage when the risk is identified, maybe it is a number allocated to the risk and a brief description of the risk. So that much would be populated into risk register, and when we will be doing the subsequent activities like the qualitative and quantitative analysis, more data can be populated. So risk register will keep getting updated. When the risks are identified, an entry for a new risk is made into the risk register. Okay, there is one other thing listed here. Um, Mohsin, can you give me an example of a risk? If I'm say constructing a house, so what could be a risk?
Sir, about what you broke, your voice was breaking for a second. A risk in what? I'm sorry, sir.
You are trying to construct a house. That is your project. What could be a risk in this job?
So there could be many types of risks. I mean, um,
Okay. Give me give me
financial risk.
give me anyone. Any one risk.
Uh, Sir, one risk I would say, for example, if the market is not stable and you're buying, you have to buy stuff, for building house, and once you have bought it already, it might get cheaper or it might get expensive. So that is a risk of starting a house right now, or either you could have waited for some time to, see if everything is stabilized.
Okay, have you heard about the 5 whys? There's a technique called 5 whys.
No, sir.
Okay, if somebody gives you, tells you a problem, well, I'm very angry today. You ask him why, right? When you ask him why, he says because I have been mistreated by the traffic police. You again ask him why. He says because he checked me, I was not wearing a belt. You ask him why. Why were you not wearing the belt? He said I was in a hurry and nobody checks it because that's why I was not wearing the belt. You said again you asked him why. You ask him 5 times why, and trust me, by the end of it, that person will himself realize that it was his fault and there is no need for anger. You understand my point?
Yes, yes.
Okay. Exactly the same rule applies to the risk. When I normally ask someone to tell me a risk, some people say time is a risk. Well, time is not a risk. Time is a word. You understand my point? What is the risk in time? Please clarify. So I need to understand the statement of the risk. Like you said, there is a risk that market prices will go up, right? Now you have to understand that whatever you have said, is it the real risk or there is something else which is the risk? So let us relate the risk to a cause and an effect. Every risk has a cause and every risk has an effect. What is the cause of this risk? Why market prices are expected to go up? Think about it.
Sir, maybe inflation or destable currency?
Okay. Due to rising inflation, market price are likely to go high. So why do we care? What is the effect on our project? So if this is the cause and this is the risk, then what is the effect of it? The effect could be that our estimates might change, right? Because of the rising
Yes.
inflation, the market prices can go up, thus rendering our estimates useless. Now this is a complete statement of the risk. Risk should not be time, risk should not be cost. Risk is a complete statement which clearly outlines a cause, a risk condition, and its effect. And that effect should clearly impact any one of the 3 things, rather 4 things: scope, time, cost, or quality. If you cannot prove that the risk you have identified has any impact on any one of these 4 objectives, scope, time, cost, or effect, then it is not a risk at all. So the risk should be in a cause, risk, effect format, and it must impact anyone, at least any one of the 4 project objectives. Only then it will qualify to be called as a risk. Now I can take it, I can debate it and debate it even further. I would say if your estimates are rendered useless, then what? What is the effect of that? You have not actually uh, imposed the effect on any of the scope, time, cost, or quality. Estimates will go wrong, then so what? So what if our estimates will go wrong is itself the risk, and the effect is something else. So the story completely changes. Now our originally what you thought was a risk is no more a risk, that is a cause. Because our estimates could be rendered useless, therefore there is a risk of abrupt changes in our risks, in our costs, which will give rise to higher level of change request. And change request automatically means that change is going to come into scope, time, or cost. So the point I am trying to make here is that when you are trying to formulate or list down the statement of the risk, it should be very well thought of, very well deliberated, and it should not be an idea coming at the spur of the moment. It should clearly show the cause, risk, effect, and the impact. Do you get this point?
Yes, yes, sir. Like it should be fully defined, not because
Fully defined and
oh,
debated. You know,
debate.
the risk we came up with after the first discussion might not even be the risk. It could even change the whole scenario. If the risk becomes the cause, then effect becomes the risk, and then we have to find another effect. So this can slide. So make it very pertinent to your project. Don't give risks, identify risks which are too generalized for the project. Okay, next is the qualitative risk analysis. And in qualitative risk analysis, I said earlier that we might have identified hundreds, rather thousands of risks. It will not be practical, it will not be possible to calculate each and every risk quantitatively and then try to find a solution for that, because this is such a huge exercise that it will take a lot of time and money itself, and sometimes this cost could be even more than the project worth. So we should not be going into the detailed analysis or quantitative analysis of all the thousands of risks. We must first sort them out, and we should choose the big risks which we feel have larger impact. We have already talked about the impact scales. So all those risks which come up to the impact scale level, they are sorted out, and remaining risks are put aside. Although we are not saying that we will not provide any protection to for those risks, but we are more focused towards the big risks. Now, I'll give you another example. Uh, if I asked you that there is a heap of stones lying there, and that contains some very big stones, some small stones, some very small stones, and even the sand and silica in it. So this huge bundle of stones, which could be thousands of stones, if I ask you to measure each and every one, how much time will it take? Inordinate number of time is going to be required for that. But what is the purpose of all this? We want to take care of the biggest risks. Is there a way that you can sort this heap of stones in such a way that all those stones whose diameter is more than 2 inches could be segregated or separated from the heap? Can you do that without measurement, without quantitative analysis?
Yeah.
Yes.
Sir, like, I mean, if you make a filter, for example, of
Exactly.
you know,
Wonderful. So you actually did give me the solution. Actually, we need to create a filter rather than measuring each and every stone. Agreed? So how much time will it save me?
yes, obviously it will save a lot of time.
Enormous time. It will save me enormous time. Then I will be worried only about those risks which are bigger than 2 inches dia. Got it? So qualitative analysis is this kind of analysis in which we look at the general qualities of the risk and we sort them out on with some filter. So all the smaller risks go down and only the selected risks come up, and then we can treat only the selected risk. We also studied the Pareto law. What did the Pareto law say?
Uh, not, I don't remember, sir.
That was 80-20 rule. 80-20 rule. This we did discuss earlier in the human resource and the resource planning, activity resource planning also. You remember the histogram and Pareto diagram, these two terms we talked about. Histogram are the vertical bars. When we were studying the quality, we said that we will develop histogram, and that is the defects. We will make the categories of defects. There are 5 types of defects, and in each there is a specific number of defects caught. In the category of slow processing, we have 25 cases. In the other category we have 30 cases. In another category we have 3 cases. So these cases, number of cases, will be the height of the horizontal vertical bar. So these vertical bars are the histogram. If I can sort them out as if the highest bar is on the left and the lowest bar is on the right, in this is called a Pareto diagram. So you see, if I can address the highest bar, then say the highest bar had 60 defects. So if I can fix that cause, I can eradicate 60 cases of defect. That was from the quality point of view. From risk point of view, uh, uh, Pareto law says 80% of problems are caused by 20% of reasons. If you can eradicate those 20% reasons, 80% of your problems will be resolved. Do you understand this point or not? This 80,
Yes, sir, yes.
Ji?
Yes, sir, like the 20% is the main uh, contributor.
Exactly. So 20% of the things will, if you take care of them, 80% of the problem will be over. Exactly. If I can sort these stones, the heap of stones, you see, if you look at the number of stones, 80% stones will go down the filter and only 20% will be retained. But if you weigh them, the big stones alone would be almost 80% the weight of the whole heap. And the sand and small stones and all that, though by number they are 80%, but their weight would be just 20%. Are you with me?
Yes, sir, exactly.
So that essentially means that if I can address those 20% risks, I can take care of 80% of the problem of risk. So that is why we do the qualitative risk analysis. We want to identify those 20% risks which carry 80% of weightage. And we don't want to waste time on 80% of risks. So, in other words, 80% of our effort will be saved. We will not waste time in minutely calculating each and every small risk. So for qualitative analysis, we will have as input the risk management plan, scope baseline. The risk register we created in the identify risk will be used as an input here and will be updated from here with the qualitative risk data which we will create, and we will use the enterprise environmental factors and organizational process assets. Now the tools we need to use here is risk probability and impact assessment has to be done. It is the filter we have to create. Probability and impact matrix will be developed, which we mentioned earlier also, but I will show you now. We also look at the risk data quality assessment. You know, we are doing all this based on some data. What is the quality of the data? Somebody is saying that this is a very big risk because I have seen it. So is he speaking truth, or is he lying? Is he fabricating? So this also depends how good quality data is there. We have to assess the authenticity and the quality of the risk data. Then risk categorizations. We must also have the risk breakdown structure, which is the categorization of the risk. Risk urgency assessment. Some of the risks need to be addressed immediately, no matter they are small or big. So such risks have to be given priority. For example, in the life of the project, there are 200 risks, and I am going through the qualitative assessment, and I have to do the qualitative assessment, but there is one risk which is to happen tomorrow. I can't tell that risk to wait till I calculate everything else. So those risks which are urgent may have to be treated on urgent basis. So this is risk urgency assessment. Which are the risks which are on some urgency and they have to be immediately treated. So I will address them first. And naturally I'll use the expert judgment. As a result, the risk register will be updated with the qualitative risk analysis data. Okay. Probability and impact assessment. This investigates the likelihood that each specific risk will occur. Right now, we are not going into the quantitative analysis. Quantitative analysis is assessing the exact value, exact damage a risk will cause. Here, as we discussed earlier, we created a criteria when we were developing the risk management plan, and we said in cost we will have a broad category of very low, low, average, high, very high. So we will assess the probability as well as impact according to this scale. Very low probability, average probability, high probability, very high probability. Similarly, impact also we will have categorized in these five areas and 5 margins. So if that criteria is already established, this is the qualitative scale on which we are going to measure each risk. This is our filter now. I will not waste time in physical calculation and each and every risk, but I will say, okay, tell me what is the approximate probability of this risk. Just tell me it is very high, it is low, it is what. Just tell me this, and you keep noting it down. And based on that, you decide whether this risk comes up in the list, in the 80% list or in the 20% list. Probability and impact matrix is something like this. For example, these are the 5 scales of probability: 1, 2, 3, 4, 5. This point 1 is very low, low, average, high, very high. Similarly, on the impact scale, we have very low, low, moderate, high, very high. Just look till here. Don't look beyond this line. So I'm only talking about threats. So if this is these are the scales or the percentages of probability, and these are the scales or the percentages of the threats, then what is the probability and impact of your risk? For example, you say that the risk I'm talking about, it has a high probability and moderate impact. So let's see what is high probability. This is very low, low, average, high. So zero point 0.7 is the high and moderate is 0.2. Multiply 0.7 by 0.2, it comes out to be 0.14. So in this box, your risk resides. Your risk has an impact of this 0.14. The overall impact is 0.14. So you will write the name of your risk in this box. Then you take another risk, say it is a very high probability but very low impact. So zero point 0.9 will be multiplied by 0.5, that comes out to be 0.045, say 0.05. So this risk will be written here in this box, this small box. So similarly, this we talked about the threats. Let us also talk about the positive risks, the opportunities. In that, the probabilities will remain the same, but the impact will be written like this. Let us do it in a way that the lowest priority, very low, goes to the extreme end and very high comes to the middle. What will happen is the very high of negative and very high of positive will be adjacent to each other. So keep identify your risks and keep writing them into the appropriate box. And in risk management plan, you should have defined this matrix, this diagram, and you should have made a shaded area which is the area which matters. This is the 20% of the risk area which you have shaded. This is your decision that what figures you want to take. What he has done is he has taken all the figures more than 15%. So this is minimum is 0.18 and the maximum is 0.72. So all the readings here, whether negative or positive, they are in this darker portion. So let us make a very huge chart of this diagram and write your risks on post-it notes and place your risk in the relevant box. So maybe there are 3 risks which come into this box. Then there are 10 risks coming into this box and 5 risks coming into this box and so on and so forth. But once they all have been placed in this matrix, I will just pick those who are on the shaded, dark shaded area. And I'll forget about all others. All others are my 80% and these risks are my 20%. These has been sorted qualitatively and this is my qualitative analysis. Did you get it?
Yes, sir, but from this perspective, like for example, if both sides are equal, because they are kind of like equalizing each other, so that means our risk is going to be 0 if both sides are equal.
Both sides, you mean threats and opportunities?
Each other, so that means we don't have any risk in terms of final.
What do you mean? What do you mean? You want to say that risks and threats and opportunities are balancing them each other?
Yes, yes, sir.
No, no, I'm not. This is just a scale. This is just a scale. So far, the risks have not been placed into it. Let us say I'm placing the risk. There is one risk which comes here. This is just hold on. Okay, there is one risk which comes here. There is another risk which comes here. There is a positive risk coming here. There is another risk coming here. There is yet another risk coming in this category. There is yet another risk coming here. There is a risk here, opportunity here, another opportunity here, a risk here, another risk here, another risk here, another risk here. So if there are 2000 risks, they will be distributed amongst these boxes. And this distribution is not going to be equal. This distribution is not going to be equal. It is not necessary that every box will have a risk. There will be many boxes which will not have any risk. And there is a high probability that the number of threats will be more than the opportunities. So there is no balancing going on. This is just our template. And template doesn't mean that the risks, the threats are equal to opportunities. It doesn't mean. It is just where that risk will be placed. Now after I have placed all the risks, identified risks on this chart, what I do is I draw a line here and I pick all those risks which are located in this region, right? So what are those risks which are located in this region?
Yes, sir. Sir, I totally understood that point. I was just saying that this diagram also tells me about the final equation of my positive and negative risks. Like I can judge how things are going to be, you know, like it gives me an overview. Like and I can see.
Is a general picture is okay, but you don't know how many risks will be where. This only you would know after you have placed the risks into the relevant boxes. So in this case, in this example, what we are talking about, we have 1, 2, 3, 4 negative risks and 1 positive risk. Means 4 threats and 1 opportunities. They have been sorted out of the many, right? Whereas there were so many risks here, there, everywhere. In every box there could be many risks. There could be 10 risks here, and so on. But these, only those who fall in the shaded area, they will be taken aside and we will take them to the quantitative analysis. We will not take all others to the quantitative analysis. Got it?
Yes, yes, sir.
Okay. Then we talk about the risk quality assessment is a technique to evaluate the degree to which the data about risk is useful for risk management. You have dirty data that cannot be authenticated. So it's a poor quality data. You should not take it into consideration. Risk categorization, as we make the work breakdown structure, we must also use a risk breakdown structure, which I example showed yesterday, in which we a hierarchical structure of risks, the main categories of risk, the technical risk category, and under the technical risk we have got another subcategory, and then we identify risk. So these categorization could be very helpful in identification of risk and later on in the analysis of these risks when we are doing the qualitative analysis. Risk urgency assessment. Risks required near-term responses may be considered more urgent to address. Indicators of priority may include probability of detecting the risk, time to effect a risk response, symptoms and warning signs, and the risk rating. So you can allocate the risk urgency assessment also. Then is a quantitative risk analysis, and in quantitative risk analysis, the chosen risks, only the chosen risks are taken up and their detailed calculation is done. Now, it is not mandatory that all the qualitative risks, the risks chosen in the qualitative risk analysis must be quantified. Quantification will be done only when you feel further elaboration is required. If you get a fair idea and fair idea from the qualitative data how to treat this risk, then you are good enough. You don't need to bother yourself with the quantitative analysis. But if there are some confusion, you want to find exact loss which will be incurred if this risk occurs, and you want to calculate it in financial figures, then probably you will have to assign exact value of probability and exact dollar value of the loss it will incur. As I gave you example yesterday, if this risk is a 10 lakh, the amount at stake is 10 lakh rupees and the risk is 10%, then when I multiply these two figures, the total impact comes out to be 1 lakh. So why this 1 lakh figure is required? Because I know that this much, this is the amount of money, the maximum amount of money this can damage me. So whatever actions I take to mitigate this risk must not be more than this amount. It should be much lower than this amount. So whatever attempt or action I take, a response I create to eradicate this risk must not exceed 100,000 rupees. If it is much lower, the better. So here we have the risk management plan, cost management plan, schedule management plan, because most of our risks are from the cost and schedule category. And if I want to, make any decisions about cost or schedule, I need to have the management plans as if to see the rules of calculating the cost and rules of calculating the schedule. Therefore, I need to have those. Risk register, which has been updated from the qualitative analysis, is received here as an input. Rest these two inputs are enterprise environmental factors and process assets. Here I do some data gathering and representation techniques. Quantitative risk analysis and modeling techniques are used, and expert judgment is used, and as a result of that, project document is updated. Now there is one other thing about quantitative risk analysis. Those risks which needs further elaboration go through the detailed calculation. All the risks which were selected in qualitative risk analysis need not to go through the quantitative risk analysis. Sometimes they can directly pass on to the next process of risk response creation. Moreover, this quantitative risk analysis should be able to tell me what is the total risk of the project, what is the total impact of all the risks on the project. So that calculation should be done here as well. So the quantitative risk analysis and modeling techniques, we have the sensitivity analysis. In sensitivity, this sensitivity analysis and Monte Carlo analysis, these are the analysis which are done from uh, schedule risk management perspective or cost risk management perspective. Sensitivity analysis helps to determine which risks have the most potential impact on the project. It helps to understand how the variations in project objectives correlate with variations in different uncertainties. Conversely, it examines the extent to which the uncertainty of each project element affects the objective being studied when all other uncertain elements are held at their baseline value. I'll tell you a very simple way of doing it. If you have three variables which impact something, then what are the various possibilities you have? there could be a number of possibilities if value of first variable is low and second is high and third is medium, what will be the impact? If all are high, what will be the impact? If all are low, what will be the impact? So there could be so many impacts. So rather than confusing yourself with hundreds and thousands of possibilities, let's take the impact of only one variable at a time. Let us say the first two variables are constant. They do not change. With the change of only one variable, what is the impact on the project? So this way, I will be able to observe the effect of each variable. Now, if these three graphs can be plotted, the area under curve of intersection would represent the area which is impacted by all three. Like you see, uh, say this is my graph. The impact of x first variable shows like this. Impact of second variable shows like this. Impact of third variable shows like this. Now this was first variable, this was second variable, and this was third variable. Now on this graph you can see that the area which comes under all the curves, which is common to all the curves, is this one area, this much. So this is the area which will be impacted if all the risks happen simultaneously. Are you getting my point? If all the risks happen simultaneously, this is the area which is going to be impacted. So I have taken one after the other and ultimately I could create this diagram. But sensitivity analysis and Monte Carlo analysis, they are not done usually by hand. They are so complex that they are done only through computer. This is called a tornado diagram. You see, if I flip a coin, there is a possibility that I'll get a heads and there is a probability I'll get the tails. So this is a 50-50 probability. But this is not always the case. Normally, risks are those risks which are more negative in nature will have more negativity and less positivity. But every risk has got a positive side and a negative side. So if you have a probability 60% probability of losing, there is a 40% probability of succeeding also. So every risk according to its size, the highest risk is represented at top, the biggest risk is represented at top, and it is the positive side of the risk and this is the negative side of the risk. Then the next biggest risk, third risk, fourth risk, fifth risk, sixth risk. So the whole diagram will form like a tornado. You see, you see this is a tornado. So this is called tornado diagram. All the risks are ordered, the biggest risks on top and smallest in the bottom, and the negative and positive side of the risk in monetary values is plotted, and then it will form a kind of a tornado diagram. Expected monetary value analysis is a statistical concept that calculates the average outcome when the future includes scenarios that may or may not happen. So you may have probability of something happening and say 60% chances of one item happening and 40% probability of something else happening. And if you go on any one of these paths, then you have yet another division of 30 and 70, and ultimately you reach to various destinations through these paths. So each path will end up with a expected monetary value. I'll show you in a problem. Then we have interviewing, and this is all we have discussed. Look at this. Can you see the decision tree? Now this is not very complex, but this will give you a very fair idea. If there is a probability that you will get project A or project B, 50-50 chances are there. You could either get project A or you could get project B. Project A has 60% of chances of success and 40% chances of failure, whereas project B has 70% chances of success and 30% chances of failure. What do you think? Which project you will go for? Emotion.
So from this, obviously, project B looks more promising.
And how did you come to that conclusion?
From the success probability.
From the success probability. But you forgot to consider the probability of project A and B, which was otherwise equal. Because that was equal, we said it doesn't have any impact. But what if the probability of going for project A was 60% and probability of going for project B was 40%, then what is your decision? Okay, look at it. You will have to multiply all the probabilities in every path. How many paths do we have? If I start from here, this is one path going from here to success. So what all falls on this path? 0.5 and 0.6. 0.5 and 0.6, multiply these two probabilities. You know, when there are more than one probabilities on one path, they are multiplied. You multiply these probabilities and you will come up with 0.5 and 0.6. The expected monetary value is 0.35. Okay, what is the monetary value of this? 0.5 into 0.4, 0.2. 0.5 into 0.7, 0.35. This was 30. And 0.5 into 0.3 is 0.15. Now, the highest value is this. Therefore, this path is the selected path. That is justified. But what if this value becomes 0.6 and this becomes 0.4? You see, everything will change. Point 0.6 into 0.6 will become 0.36. 0.6 into 0.4 will become 0.24. 0.4 into 0.7 becomes 0.28. And 0.4 into 0.3 becomes 0.12. In this case, this is the winner. And the path is, this is the biggest path. So these are called decision trees on which we can calculate this impact. Now, this is another example in front of you. You have a decision to make. If you do not make this decision, you don't spend any money. If you decide to go ahead with this decision, 70% of production going into successful are the chances, and 30% of the chances the production will not be successful and you will suffer a loss of minus $200,000. If the production is successful, 30% chances are that you will go in high demand and the ultimate profit will be 550,000. If you go in low demand, which has a 70% chance, the probability would be 100,000. Again, the same rule, we will calculate each path. So my first path is going from here to here, but all are the values 0.7, 0.3, and because a monetary value is also provided, so this is my expected monetary value. So 0.5 into 0.7 into 0.3 into 550,000 is exactly this thing. I will get $1,15,500. So this is 1,155,100. Now coming on to the other path, if I go on this path till here, I have got 0.7, 0.7 and minus 100,000. So 0.7 into 0.7 into minus 100,000 comes out to be minus 49,000. And the third path is from here to here. In this 0.7 does not come in. So simply we have 0.3 into minus 200,000, which is minus 60,000. So these are the expected monetary values of all the branches. What is the weight at this place? This branch is worth positive 1,15,500. Second branch is worth minus 49,000. Third branch is minus 60,000. So if I add them all up, the ultimate benefit I get here, benefit or loss, whatever, is $6,500. So there is a high likelihood that if I go for this decision, I will be in profit. I will make $6,500. But if I don't make this decision, I do not get anything at all, zero. So in this specific case, your decision is you must pursue this decision. If the value was negative, the overall value was negative, then I would say do not pursue this decision. Right. Another example?
Sir, one question.
Yes, please.
Sir, though we are calculating it, looking at the final success of the project, I mean, that must be the situation if everything happens along the path we have defined.
Right.
So what if it ends up at point A or point B? So how do we consider those things?
Okay. You see, if you end up on point 1, then you straight away make 1,15,500. Then 2 and 3 does not matter. But how are you sure that you will end up with that situation? If you end up with the second situation, you get a loss of 49,000, and if you end up in the third situation, you will get a loss of 60,000. Now you are not sure what will happen, so you will have to kind of take a cumulative effect of them all, that is the total load coming on the branch. Like if like we take average of everything. If I have got more than one probabilities, I take average of everything and say this is the average position of the case. We have more probability of winning. So in this case, we have more probability of winning in this decision because our value is positive. Is it okay?
Yes, sir. And sir, if we don't consider the value,
If
and
you
if
do
we
not
just
have
go,
the monetary value given, then we will calculate based on the percentages only. If the 550,000 and minus 100,000, these values are not known, then we will calculate only the probabilities. 0.7 into 0.3, 0.7 into 0.7, and on third is 0.3.
oh, okay, sir. Okay, thank you.
Now, this is a very good example of expected monetary value. Let us listen to this case very carefully. It says you have a decision to make, whether you build or you upgrade. You are trying to build or upgrade a plant. If you build the plant, you will have to invest $120 million. If you upgrade the plant, you have to invest $50 million. 60% chances are going in strong demand. In case of new plant, you will have a revenue of 200 million. 40% chances are weak demand, a revenue of 90 million. Upgrade case, 60% chances strong demand, 120 million. 40% chance weak demand, 60 million. So let us calculate what is the net profit. In first case, we have 120 and we are earning 200. So net profit we are making is 80 million in first case. In second case, we have a loss of 30 million. Third case, we have a profit of 70 million. Fourth case, a profit of 10 million. Now, upper two cases are based on this branch. So let us calculate the weight on this branch. On this branch, the weight is 0.6 into 80 plus 0.4 into minus 30. It is written here. 0.6 into 80 plus 0.4 into minus 30. This is the cost of, this is the total benefit of building new plant, and that comes out to be 36 million. If I calculate the other branch, upgrade plant, other option, in this option, I have 0.6 into 70 plus 0.4 into 10. That comes out to be 46 million. So which is better for you? Should you build a new plant or upgrade this plant?
Upgrade.
So that's why my build or upgrade decision would be upgrade. Okay, then we have the risk responses. Risk responses are pretty simple. Once we have quantified our risk, we will create the risk responses. In this, we have strategies to interact with the negative risk and strategies for the positive risk. Then we have contingent risk responses and expert judgment. We will use the risk management plan and risk register as input, and project management plan and project documents will be updated. You see, if there are negative risks, the very first thing we do is we try to avoid the risk. Rather, I think I should discuss the risk response tomorrow because the next class is about to start and
Sure.
I will not be able to complete it. So we can discuss it tomorrow.
Sure, sir.
So any questions?
No, sir. It's good. It's good enough.
Okay, let's call it a day then and see you tomorrow. Thank you very much.
Thank you very much, sir. Thank you. Good night.
Take care.